is the James Webb Space Telescope looking at our first clear technosignature, artificial lights on an object that traveled between the stars. In August 2025, JWST trained its infrared eyes on a mysterious visitor called 3I Atlas. Some channels say artificial lights. Scientists say extraordinary claims require extraordinary evidence. Tonight we'll examine the data, separate facts from hype, and ask, could this be natural? Or might we be glimpsing something engineered? If you're new here, we dig into big space stories with careful science and clear explanations. In this episode, we'll cover the discovery of 3I Atlas, what JWST and other telescopes actually observed, why some people are calling it artificial lights, what natural explanations fit the data, what an actual technosignature would look like, and what the next steps are. I'll include on-screen keywords and sources, so you can check the primary reports yourself. Interstellar objects are visitors that originated outside our solar system. We've only confirmed a few: Oumuamua in 2017, 2I Borisov in 2019, and now 3I Atlas in 2025. They're rare and valuable. Each one is a sample of material formed around other stars, giving us insight into planetary formation, chemistry, and possibly life beyond the solar system. Explain key terms briefly for the audience: comet, nucleus, coma, tail. What they are and how we observe them. Spectroscopy. How instruments like JWST split light to identify molecules: water, CO2, organics. Infrared observations. Why JWST's NIR spec and other instruments are crucial for detecting gases and thermal signatures. 3I Atlas was first detected by the Atlas survey in July 2025. Initial ground-based imaging showed a bright, active object with a coma and tail. Early estimates of its size were revised as better data came in. Hubble, ground-based observatories, and JWST joined the effort to measure its size, composition, and trajectory. Discovery date: July 1st, 2025, Atlas. Classification: reclassified as interstellar, the third confirmed interstellar object. Size estimates: Hubble constrained the nucleus with upper-lower limits. Estimates ranged in news reports with uncertainties. On August 6, 2025, JWST observed 3I Atlas with its near-infrared spectrograph, NIR spec. The spectra showed unusually high levels of carbon dioxide relative to water, one of the highest CO2 H2O ratios recorded for a comet-like object. The images and spectroscopic data revealed a bright coma dominated by CO2 emissions and an active tail. Those are the observational facts coming directly from NASA and independent report. Explain significance. CO2-dominated coma is unusual because many solar system comets show stronger water signatures. High CO2 suggests formation in a colder or chemically different environment, perhaps a different protoplanetary disk. 3I Atlas was first detected by the Atlas survey in July 2025. Initial ground-based imaging showed a bright, active object with a coma and tail. Early estimates of its size were revised as better data came in. Hubble, ground-based observatories, and JWST joined the effort to measure its size, composition, and trajectory. Discovery date: July 1st, 2025, Atlas. Classification: reclassified as interstellar, the third confirmed interstellar object. Size estimates: Hubble constrained the nucleus with upper-lower limits. Estimates ranged in news reports with uncertainties. On August 6th, 2025, JWST observed 3I Atlas with its near-infrared spectrograph, NIRSpec. The spectra showed unusually high levels of carbon dioxide relative to water, one of the highest CO2 H2O ratios recorded for a comet-like object. The images and spectroscopic data revealed a bright coma dominated by CO2 emissions and an active tail. Those are the observational facts coming directly from NASA and independent reporting. CO2-dominated coma is unusual because many solar system comets show stronger water signatures. High CO2 suggests formation in a colder or chemically different environment, perhaps a different protoplanetary disk. Now the claim: JWST detected artificial lights on 3I Atlas. Where did that come from? Short answer: social media and a handful of sensational videos amplified ambiguous imagery and preliminary language into a definitive claim. Multiple YouTube creators and reels used phrases like artificial lights and editorialized the JWST images. But there's an important distinction between bright central emissions in infrared and engineered lights turned on by an intelligence. Cite examples of sensational coverage and point out they are not peer-reviewed science. Explain common patterns. Creators often magnify color-mapped infrared images and use rhetorical leaps from bright, light source, artificial light, without quantitative evidence. Let's be very clear about what JWST's spectra and images can tell us, and what they can't. JWST can identify molecular composition, like CO2, H2O, organics, measure dust properties, map temperature distributions, and image structural asymmetries in the coma. JWST cannot, from a single set of infrared images, definitively detect visible artificial lights as you'd think of on a spacecraft. Infrared brightness can arise from hotspots, concentrated gas emissions, sunlight reflected off dust, or thermal emission from sun-warmed material. Key point to emphasize: a central bright spot in JWST's infrared images is not proof of artificial lighting. It's like seeing a glow through fog from an airplane at night. It might be cabin lights, but it might also be the engine, a reflection, or a hot surface. Some prominent scientists have raised the question of non-natural explanations. The debate flared after publications and preprints noted the object's unusual size, trajectory, and chemistry. Harvard-affiliated scientists, historically vocal about engineered explanations for interstellar objects, are in the conversation, and sensational theories spread quickly online. But the mainstream community urges caution. The majority of researchers prefer natural explanations unless the extraordinary interpretations have been suggested. But leading observatories call for more data and peer-reviewed analyses before drawing conclusions. Data force a different conclusion. Let's list plausible natural scenarios that explain JWST's observations without invoking aliens. CO2-rich nucleus. The object formed in a different protoplanetary environment with more CO2 ice. As it warms, CO2 sublimates strongly, producing a bright infrared signature. Live science, localized outgassing, or jets. Comets often have jets that produce bright, compact features in images. Jets can appear as bright spots, especially in infrared. Reflection and thermal emission from dust. Concentrations of dust can reflect sunlight and re-radiate heat, showing up as bright regions in JWST's bands. Calibration and image processing artifacts. Color mapping, stretching, and false color rendering for public images can emphasize features that look more dramatic than they are. All of these are consistent with JWST spectroscopy and with how comets behave. None require intelligence to explain them. If we're hunting for technosignatures, signs of technology beyond Earth, what would robust evidence look like? Scientists look for anomalies that are inconsistent with natural physics and chemistry. Narrowband radio transmissions, patterns in light curves that encode information, spectral lines from industrial chemicals out of chemical equilibrium. or persistent point-like visible light sources with power outputs and colors inconsistent with reflection or thermal physics. A single bright infrared blob is not enough. We'd need repeatable, multi-wavelength, time-resolved, and preferably localized signatures that can't be explained by natural processes. Provide a short checklist on screen. Repeatable, multi-wavelength, information-bearing, inconsistent with known physics. Mention SETI protocols for verification. What happens next? Scientists will continue multi-observatory campaigns. More JWST data, Hubble imaging, ground-based spectroscopy, radar where possible, and Mars-Jupiter mission opportunistic observations. The key is repeated observations over time to measure changes, identify outgassing patterns, and refine composition. Independent teams will publish papers. Peer review matters, and the public should expect updates that may revise early impressions. The James Webb Space Telescope gave us an extraordinary dataset on 3I Atlas, a CO2-rich, active interstellar visitor that is scientifically fascinating. The claim, artificial lights detected, is a leap beyond what the available evidence supports. Right now, the responsible scientific stance is curiosity plus skepticism. Be open to unexpected possibilities, but insist on rigorous evidence. Whether 3I Atlas turns out to be a natural comet born around another star, or something far stranger, the observations are already expanding our understanding of the galaxy. NASA. If you enjoyed this deep dive, like and subscribe for careful, sourced coverage of major space stories. I'll link the primary observations, NASA releases, space.com, and live science articles, and the most relevant preprints in the description so you can dig in. Drop a comment. What do you think of the evidence, natural or engineered? I'll read the best thoughts in the next episode.